Hey guys, welcome back to StatsB. So we've learned about how data is just sometimes too large to interpret and make judgments on. Hence, we make use of descriptive statistics in the form of summaries, tabulations, diagrams, and graphs covered in chapter 2.1 and 2.2 to better understand and gain useful insights from the data. So in this section, we will focus on the numerical aspects of data descriptions, essentially the numeric facts about the data. So I will cover the measures of central, location, and variation for this video. First, we would like to know where our data is centrally located. To gain this information, we look at measures of central tendency such as the mean, otherwise called an average, the median, and mode. And so then these values then give us a numeric value that the other data values are centered around. Each measure is then calculated based on the context of each scenario and which measure would best describe the data's central point. Let's start by computing a mean for ungrouped data. The mean is calculated by dividing the sum of all data values by the number of the data values. The mean is denoted differently for populations and samples, as you can see. The mean for populations is the Greek letter mu, and for samples it is x bar. The capital letter N is the number of values for a population, and the small letter n is for samples. Now let's consider the age of 15 sampled grade 5 students here. So what is done on this example is that we've taken 15 students that are in grade 5 and we collect the variable age. So we're just trying to see where the age is centrally located, or what is the expected age of a grade 5 student. Okay, so what do we do? So since this is a sample, we use x bar, and then what we do is we sum all of the x's, and your x's here would be your 9, this 10, the 9, the 12, the 11, the 10, the 10, and so on up until you get to this 10, then your 11, then your 12, and then what you do is you divide by n. This is going to be a small n because this is from a sample. What you get is a 10.4. What does this 10.4 then mean? So this basically means that if you were to pick a student in this grade 5 class, you would expect that student to be 10 years of age. Right, so that wraps up our first measure of central tendency, the mean. And then next up we have a median. So this median is a value that has half of the data points less than or equal to it, or half of the data points greater than or equal to it. So you'll see by an example that we will consider here again. So what we do is we use the example from our previous mean calculation where we looked at the age of 15 grade 5 students. So the first thing you would want to do when you're calculating a median is to order the data from smallest to largest. So 9 being your smallest will be the start, and then you'll see that 13 is your largest number and it's right at the end. So you order from smallest to largest. And then secondly, your next step would be to find the position of the middle data point. This is the position, right? It's not the median as yet, but you're trying to find the position of it when you've ordered from smallest to largest. So here's another thing to keep in mind here is that if your n is odd, then this is the position that it'll sit in. This 1 over 2 times n plus 1, this is the position where it will sit at. Right, so plugging in your n, remember your n is the sample size, right? We have 15 students that we picked out, and then just plug in the 15. So 1 over 2 times 15 plus 1, you get 8. So what does this mean? This means that our median is sitting in the 8th position. So you go back to our data that we ordered from smallest to largest and count 8. So we say 1, 2, 3, 4, 5, 6, 7, 8, and this is where your median would be sitting at. So what number corresponds to the 8th position? 10. There we go. You've just literally found your median. So therefore your median is 10. So this basically means that the middle value for this data is 10. And what does this mean? It just essentially means that you have half of the students being 10 years or older and half of the data being 10 years or younger. Alright, so let's now consider a situation where our sample size is an even number. So say we took 8 students instead of the 15 students like in the previous example. So essentially we just do the same thing. First things first, we order the data from smallest to largest, and then we find the position. So in the case where we have an even number of the sample, position of the median will be between two values. So it will be between n divided by 2 and n divided by 2 plus 1. So that's where your middle value will be sitting there. Plug in the 8 into these two equations and you get 4 and 5. So in the fourth and fifth position, so go back to your data that's been ordered from smallest to largest and count. So you have 1, 2, 3, 4, and 5. So these are the values that you must consider. So this is where your middle value will be sitting. So then what do we do with these numbers? The 10 and the 11, what do we do with them? So we take the two data points between the fourth and fifth position, add them up and divide by 2. So we take the 10 and 11 as we did here, divide by 2, and then we get a value of 10.5. So what does this value mean? It just essentially means that half of the ages are going to be greater than or equal to 10.5, and half of the ages will be less than or equal to 10.5. Cool. So last but not least, we will take a look at the last measure of central tendency, which is called the mode. Right, so what does this mean? So basically, this is a number or a data point that appears most frequently or appears the most. So let's consider the ages of the 15 grade 5 students and let's see which age appears the most. So we have 1, 2, 3, 4, 5 ages. So we have 9-year-olds, 10-year-olds, 11-year-olds, 12-year-olds, and a 13-year-old. Only one 13-year-old. And out of these ages, 10 appears the most because there's 1, 2, 3, 4, 5. There's 5 students that were 10 years old, and hence the mode is 10 for these 15 students. Second example is where we took the 8 grade 5 students and we have 9-year-olds, a 10-year-old, two 11-year-olds, and a 14-year-old. And when you do your counts, you'll see that 1, 2, 3, 4. We had 4 9-year-olds, and they were the ones that appeared the most. Guys, I guess this is the easiest and the most straightforward of them all. Right, so that's where I will end off measures of central tendency. So we've discussed the mean, the median, and mode, and here's when to use each one of them. So we would like to use a mean when your data is symmetric and it has no outliers. We would like to use the median when the data is non-symmetric and your data has outliers. So this essentially means that if your data looks like this, if the distribution of your data looks like this, then most probably we would want to use a median. But if your data looks like this, we definitely want to use a mean to describe the central location of your data. And then finally, when do we use the mode? So we most likely use the mode if we are generally interested in which value appears the most. And also here's a little couple of facts about the different distributions and where the mean, median, and mode would sit. So for symmetric data, usually the mean is equal to the median and also equal to the mode. All of these values are equal to each other. And then for when your data is positively skewed or skewed to the right, usually your mode is less than the median and the median is less than the mean. Right. This is just extra information. You don't have to know this by heart, but it's actually good to know. And then finally, you find that if your data is negatively skewed, your mean is less than the median and the median is less than the mode. Right, so that brings us to the end of the measures of central tendencies that you should know and where to use them and how to actually even calculate them. Alright, so now we will look at measures that will describe the spread of the data also sometimes called measures of variation or measures of dispersion. So these measures also would give us an idea how basically our distributions would look like. Either it is tall or narrow, or maybe wide and short, as this one over here. And then amongst our measures, we have what we call a variance, and then we have a standard deviation, and then we have a range. So please also be mindful that this is how we represent them or denote them. So this is called sigma squared. This is for populations, and then we have a S squared, which is for a sample variance squared. And then a standard deviation is denoted as sigma for population and small letter s for sample standard deviation. And then your range is essentially your maximum value minus the minimum values. Alright, so first things first, let us discuss the standard deviation. So this is a measure that tells us how closely a data point is clustered around the mean. So we have a mean here at the center, and then the standard deviation gives us an approximation of how close the x values that are centered around the mean are. So the standard deviation is obtained by taking the positive square root of the variance. So if you find the variance first, then you can definitely find the standard deviation by just taking the positive square root of that variance. Now let's jump and see how a variance is calculated. So again, we have a variance. Population variance is denoted as sigma squared, and we have a sample variance denoted as s squared, small letter s squared. Now, this is the equation. So what do? We sum the squared differences between the data point and the mean. So it could be either the population mean or your sample mean, dependent on what you are calculating. So it could be the population variance or the sample variance. So in the case of a population variance, it is the sum of the squared difference of the data point minus the population mean divided by your big N. So remember, I did say that your big N denotes the population size. And then for sample variances, it's exactly the same way we square the difference of the data point and sample mean. We sum it up and then we divide by n minus 1. This is really important, guys. It is n minus 1. It's really important here to note the differences between these two. So then after we are then finished calculating this, we can now move on to calculating the standard deviation obtained by just taking the square root of the variance, and here's what we come to. These standard deviations: a population standard deviation denoted by a sigma, and a sample standard deviation denoted by a small s. Right, let's now move on to an example. Here's a quick example here where we consider a sample of 4 statistic test marks. So we collected 4 test marks from students that do statistics. They wrote a test and we collected their marks, and we are trying to find the standard deviation and also even the variance. First things first, what we want to do is first get the mean. And you might notice and also be wary that we are using the sample mean. Why are we using the sample mean? Because the example did tell us that this is a sample of 4 students. Hence, we are using this equation. So what do when we are calculating a sample mean? We essentially take all of the data points, so all of the marks, add them up, and then divide by the number of sample, which is 4. Right, so you get 240 divided by 4, and then your answer is 60. So what does this mean? This means that the average mark that the students got was 60%. Next step is to calculate the sample variance. Sample variance because we are dealing with a sample here. Hence, we are using S squared. This is going to be equal to the sum of the squared difference of the data points and your sample mean divided by n minus 1. Really important here that we use the appropriate equation. Cool, so this is how this looks like. So basically, we already did calculate a sample mean, which we got to be 60. What we do then, we take our marks, each one of them, find the difference and square it. Find the difference, square it. Find the difference, square it. Find the difference, square it. And we add all of this up, we divide by 4 minus 1. And this is the answer we come up to. So right, this right here would be your sample variance, your S squared. And then to calculate the sample standard deviation, what we do is we take the sample variance and put it under a square root, and then we get a value of 19.25. So this value basically will tell you how close the marks are from the 60. Next up, we then look at the range. So the range is basically the measure that will give us the distance between the maximum and minimum value. Let's revisit back the ages of those 15 students. And this is how we then find a maximum and minimum. And so this is then how we would find our range. So our range in this case would be 13 because this is the largest value that we got, and minus 9 because this is the smallest value that we got, and then we get a value of 4. Then this basically is your range. And then we also given a second example where we had 8 students where the maximum age was 14, then we subtract the minimum age, which was 9, and then we get a value of 5. Alright, so we can now see how these two are different. It's fine that this has a larger distance, although there's less students, but then this one has a smaller distance between the ages, although they have more students. So it's really important. This gives us some insight on basically how stretched out our data is. Alright, so this brings me to the end of this video. So up next I will be discussing measures of precision. Thank you for watching and see you next time.